In the first two videos on supply and demand, I introduced mathematical examples of demand and supply functions. This video applies those functional forms to the shifts to the supply and/or demand curves that we discussed in the previous video. Recall from the previous video that I presented a demand function of QD equals 15 minus 2p and a supply function of QS equals negative 25 plus 8p. We can use these equations to calculate the equilibrium price and quantity for this particular combination of supply and demand curves. Since a market equilibrium exists when the demand curve intersects the supply curve, we will set the demand function equal to the supply function such that QD equals QS. Doing so yields an equilibrium price of $4 and an equilibrium quantity of 7. What were the intermediate steps to get PE equals $4 and QE equals 7? Well, by setting the demand function equal to the supply function, we get 15 minus 2p is equal to negative 25 plus 8p. Moving the negative 25 to the left-hand side and the negative 2p to the right-hand side, we then get 40 equals 10p. Solving for p, we get that the equilibrium price is 40 divided by 10, which is $4. We then plug $4 into either the demand or supply function to get that QE is equal to QD, which is equal to 15 minus 2 times 4, which is equal to 15 minus 8, which is 7. Or, plugging into the supply function, we get QE is equal to QS equals negative 25 plus 8 times 4 is equal to negative 25 plus 32, which is equal to 7. By definition, you should get the same answer regardless of whether you use the supply function or the demand function, since again, the equilibrium quantity means that quantity demanded equals quantity supplied. Given that our original example is copper, we interpret PE equals $4 as the equilibrium price that makes it such that the amount of copper that consumers want to buy is exactly the amount of copper that producers made. If the market price was not equal to the equilibrium price of $4, then we would be in disequilibrium. In particular, if the market price was above $4, then there would be a surplus of copper since the quantity supplied is greater than the quantity demanded. On the other hand, if the market price was less than $4, then there would be a shortage of copper since the quantity demanded is greater than the quantity supplied. So PE of $4 and QE of 7 is associated with our initial equilibrium like P0 and Q0 in the previous video. We discussed how the equilibrium price and equilibrium quantity can change when there is a shift in one or both of our curves, so let's see how this is represented in our mathematical example. Notice that the top bullet point relates to a change in demand. A recession in the US and Europe that resulted in the cancellation of copper-using projects would decrease demand due to a drop in the popularity of copper. The demand for telecom services, which relies heavily on copper wires, weakening is also an example of lower demand for copper. And a larger number of purchasers expecting a lower future price would decrease the demand for copper today. All three of these scenarios shift the demand curve to the left. On the other hand, the bottom bullet point is associated with a change in supply. A recession leading to lower wages for workers would increase the supply of copper. Similarly, technological improvement would also increase the supply of copper. Finally, China releasing some of its previously undiscovered stockpiles of copper would flood the market with a new source of copper supplies. All three of these scenarios shift the supply curve to the right. Based on our table covered in the previous video, we can expect equilibrium price to decrease, but we are unsure what would happen to equilibrium quantity. If the demand curve shifted by more than the supply curve, then the equilibrium quantity will ultimately decrease. But if the supply effect dominates the demand effect, then we should see a higher equilibrium quantity. Our mathematical example will help us determine whether the demand curve shifted by more than the supply curve or vice versa. Recall from the demand video that the inverse demand function was P equals 7.5 minus 0.5 QD1. Let's suppose that the new demand function becomes QD2 equals 12 minus 2p. In order to determine that this is associated with a demand curve that shifted to the left, let's invert this new demand function by solving for P. Moving the 2P to the left-hand side and QD2 to the right-hand side, we get 2P is equal to 12 minus QD2. Dividing both sides by 2, we solve for P by getting P is equal to 6 minus 1/2 QD2, or 6 minus 0.5 QD2. Comparing this with the original inverse demand function of P equals 7.5 minus 0.5 QD1, we can see that the new demand curve has the same slope as the original demand curve, but with a lower y-intercept. This precisely describes the difference between D0 and D2 in the previous video. So we have confirmed that our new demand function is associated with a demand curve that is shifted to the left of our original demand curve. Recall from the supply video that the inverse supply function was P equals 3.125 plus 0.125 QS1. Let's suppose that the new supply function becomes QS2 is equal to negative 18 plus 8P. In order to determine that this is associated with a supply curve that shifted to the right, let's invert this new supply function by solving for P. Moving the negative 18 to the left-hand side, we get that QS2 plus 18 is equal to 8P. Dividing both sides by 8, we get QS2 divided by 8 plus 18 divided by 8 is equal to P. Rearranging the left-hand side and the right-hand side, this becomes P equals 18 divided by 8 plus 1/8 QS2, or 2.25 plus 0.125 QS2. Comparing this with the original inverse supply function of P equals 3.125 plus 0.125 QS1, we can see that the new supply curve has the same slope as the original supply curve, but with a lower y-intercept. This precisely describes the difference between S0 and S1 in the previous video. So we have confirmed that our new supply function is associated with a supply curve that is shifted to the right of our original supply curve. Let's use the new demand and supply functions to calculate our new equilibrium price and quantity. Again, we anticipate the equilibrium price will decrease, but we're unsure about whether the equilibrium quantity will increase or decrease. As discussed earlier in this video, we will set the new demand function equal to the new supply function in order to analyze the new market equilibrium. Doing so yields an equilibrium price of $3 and an equilibrium quantity of 6. The new equilibrium price is indeed lower, and now we can determine that the shift in the demand curve was larger than the shift in the supply curve, since the equilibrium quantity decreased from 7 to 6. What were the intermediate steps to get the new equilibrium price and quantity? Well, by setting the new demand function equal to the new supply function, we get 12 minus 2p is equal to negative 18 plus 8p. Moving the negative 2p to the right-hand side and the negative 18 to the left-hand side, we get that 30 is equal to 10p. Solving for p, we now get that the equilibrium price is 30 divided by 10, or $3. Plugging in $3 into either the new supply function or the new demand function, we can find that the equilibrium quantity QE is equal to the quantity demanded, which is 12 minus 2 times 3, or 12 minus 6, which is equal to 6. Alternatively, the equilibrium quantity is equal to the quantity supplied, which is negative 18 plus 8 times 3, or negative 18 plus 24, which is also equal to 6. As with our initial equilibrium, you should get the same answer for equilibrium quantity, regardless of whether you use the demand function or supply function. This graph illustrates our numerical example. Notice that the y-intercept and slope for all 4 curves match with the numerical values in our 2 inverse demand functions and 2 inverse supply functions. The graph also shows that the demand curve shifted to the left and the supply curve shifted to the right, so the initial equilibrium is represented with the letter A, and our new equilibrium is denoted as B. Our equilibrium price went down, as expected, from $4 to $3, and our equilibrium quantity decreased from 7 to 6, since there's a slightly larger shift in the demand curve compared to the shift in the supply curve. So the graph is consistent with our table and mathematical equations. I encourage you to review the practice problems and their solutions that I provided on Moodle to make sure that you fully understand the concepts introduced in these recordings. Feel free to email me with any questions that you have.